This learning target is a really straightforward, simple one. Basically, we're expected to be able to use a certain equation that relates voltage, charge, and stored energy or potential energy for a capacitor. So the equation can be written out a couple of different ways. So it's U for potential energy. The lowercase c, or the capital C that's a subscript there, that's for a capacitor, the internal energy, or sorry, the potential energy of a capacitor. That's going to be equal to 1/2 times the charge, Q, times the voltage, that really should be delta V, but okay, I'll stop harping on about that. So voltage, 1/2 Q times V. Potential energy is 1/2 Q times V. So here, again, that's potential energy. And that'll be measured in joules. Q is the charge. That's the charge stored on each of the plates. So it might tell you that there's 500 microcoulombs of positive charge on one side and 500 microcoulombs of negative charge on the other side. That's fine. We'll just use 500 microcoulombs of charge. It's always going to be the same on both sides. And then V is the voltage, which is measured in volts. Pretty easy one to remember, at least. Then we also had this relationship that we worked with in the last video, that we can write Q is equal to C times V. And so as a result of that, if we plug in, instead of Q, put C times V, we'll get C times V times V. So 1/2 times C times V squared. So this is also written as 1/2 CV squared, where again V is voltage and C is the capacitance, which is in units again of joules per volt. How many joules of charge we can build up for every volt of voltage or volt of electric potential that we put across this capacitor.